In scheduling, how we can sequence a work for each resources we have is also a challenging and problematic task. How we can do it? Let's see in this video.
Let's continue discussion on the sequencing model. In the previous video, we already discussed about the assignment model, which is assign a job to a resources. In this case, we discuss one-to-one assignment. And in this sequencing model, there is several jobs waiting to be assigned for one resources. In this case, is work center. So the sequencing model is specifies, in this case, specifies the order in which job should be performed at specific resources or work center in this case. The priority rules that we will use to dispatch or to sequence the job, there are several priority rules. Each of them has its own advantage and disadvantage. So the first priority rule is first come, first serve. So when the job is coming first, and then they will directly dispatch to the work center. And the second is shortest processing time. So we take a look at the job where the job having the shortest processing time. That is the priority to be done first. Opposite from the shortest processing time is longest processing time. So in LPT, so we prioritize the job having the longest processing time to be processed first. And then the other processing rule is earliest due date. So having the closest due date, this is the priority. The job that has the closest due date become the priority. Take a look at this example. Let's try to apply the sequencing rules to these 5 jobs. For example, we have job A, B, C, D, and E with the processing time in the measure of days. So it's like this. So A having 6 days to process, and the due date is at the days 8. In this case, B has a processing time of 2 days, and due date is to date number 6, and so on. So we have this situation. How we can apply the sequencing rule to this 5 job? Let's take a look. With the FCFS resulted with the sequence of A, B, C, D, and E, because we assume that this job is coming in to the shop floor of the factory is sequentially coming from A, B, C, D, and then lastly D coming in. So here we can calculate, based on this situation, we can calculate the flow time. The flow time. How we can calculate the flow time is like this. For example, job A coming in, have 6 in this case, so the accumulated time should be 6 in here. And then job B is processing next, so having time of 2, and then the flow time should be 6 plus 2. So here becoming 8. So this is actually 6 plus 2. And then job C coming in, so 8 in this case, and the flow time is 8 plus 8 coming from here, so equal to 16. So this is kind like accumulation of the job working time. When we compare with the due date, the information that we already known before, we can have, or we can evaluate the job lateness. For example, the completion of the job A is at time 6 and the due date is 8, so there is no lateness. It's okay, so we can meet the due date in this case. But the job B in this case is finished at day number 8, but the due date is day number 6, so we late about 2 days. And then job number C is also like that. We don't have the lateness. Job number 4 having lateness 4 and job number 5 having the lateness 5. So in total, job lateness will be 11 and the float time in total is 77, while the job processing time in total is 28. What is the performance of this sequencing example? So when we use the FCFS, first come first serve, and then the utilization metric we can calculate is 28. This is total time divided by total float time. So the resulted in 36.4 utilization, and the completion time, average completion time is sum of the total time 77 divided by 5 resulted in 15.4 days. 5 in this case is number of job. Then average job in the system in total, so it's become the sum of the total times 77 divided by total job work time, so 28. So this is opposite with the utilization matrix, so resulted with the 2.75 job that is remain or in the system at one time. And lastly is a lateness is total lateness days divided by number of job 5 equal to our lateness is 2.2 days. With the shortest processing time, we have the result of sequencing is BDAC. Why BDAC? Let's take a look at the B has the shortest processing time, so this is the first priority, and then next is D. D have the 3, so this is priority number 2, and then job A having the time 6, so this is priority number 3, and so on. We continue C and E. Here, with the same calculation, we can have the float time. We can calculate the float time and job lateness. With resulted, the float time 65 and job lateness 9. And the total processing time for all of this job is the same, yes, 28. So how's the performance of this? So the average completion time becoming 30 days, and utilization metric is 43.1, and the average number of job in the system is 2.32, and the average lateness is 1.8. So as we can see, in general, in terms of lateness, it is better using this SPT rule. The next sequencing is earliest due date. Having the earliest due date, we should make the priority first. It's becoming priority. So it's resulted with this sequence. So B have the due date this one, 6. A having a due date of 8, and D 15, 18, and 23. So this is becoming the priority number B and number 1, A number 2, D number 3, and so on. With this sequencing rule, we have the float time is 68, yeah, in this case. And job lateness, this is the smallest among the previous sequencing rule that we already discussed. So this is 6 in this case. And this is the performance. We have the average completion time 30.6 and utilization 41, and this one the number of jobs in the system 2.43, and the lateness is 1.2 days. So this is the job lateness. The smallest one is in this earliest due date. The last sequencing rule is the longest processing time, which means that we have to make a prioritize to the job having the large processing time first. So here we can see that the sequence becoming ECADB. So we make a sequence based on the processing time in here, and the float time, accumulated float time, is becoming quite large number, big number, and the lateness also becoming larger than with comparing with the other sequencing rules. And when we calculate the performance, it's like this. So average completion time is 20.6 and utilization metric 27.2, 3.6, 3.68 job is the number of the job in the system, and lateness is, this is quite big, 9.6. In summary, we can see that the advantage and the disadvantage of the sequencing rules, the sequencing rule. So its sequencing rule we can see in here. From the average completion time, which is the days, the shortest processing time is best to use. From the utilization metric perspective, we can see that here again the shortest processing time is also best, and number of jobs in the system, this one we should take a look at the lowest one or the minimum one. In this case is still the shortest processing time, and from the average lateness we should find out which one that minimize the lateness. So the earliest due date is the best one in this case. So this is the summary. If we take a look at all of this, yeah, so if our company in here put that our company have to reduce the lateness, and then we should use the earliest due date priority rule in our scheduling. I hope those priority rule give you a sense about how we can make a priority. We can sequence the job to the resources. See you again in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.